1-4, solving absolute value equations today. And the essential question, how can you solve an absolute value equation? Letter A, or exploration 1 says, consider the absolute value equation, the absolute value of x plus 2 equals 3. Okay, first, go ahead and tell your neighbor what you know about absolute values.
Yeah, but if it's like this, and then like that, then it would be, so if the negative that side, then it would be negative 11, even if it was like that.
Okay, volunteer, what do you know? Quinn, what do you know? Their absolute value is always positive. Why is it always a positive? Yes, Mac?
Because it's in the positive case.
No, not quite. We will talk about positive cases, though. Cassie? Good. Absolute value, these little symbols right here mean absolute value, and it tells you how far away something is from 0. It means distance from 0 on a number line. So since it's a distance, that means a distance is always positive. That means anything that comes out of this absolute value will change to positive if it's not already positive. Okay? So it says, describe the values of x plus 2 that would make this true. Okay? And use that description to write two linear equations to represent the solutions. So right now, I want you to just talk with your groupies. How could you find, or what values do you need in here for the absolute value of this to equal 3? What two values are 3 units from 0 on a number line? And what equations would you use to do that? Okay? Talk about it real quick. What values of x plus 2 make the equation true? Like, what do we need in here for this to be true? Go ahead. Logan? 1? Is that true?
That is true.
Okay, so the x would have to be 1, making the entire thing what? 3. So we need x plus 2 to equal 3. And Logan, you said that would make x equal 1. So if we solve that equation, we get x equals 1. Would any other value inside here work other than 3? Okay? Alright. So if I put a negative 5 in for x, I would get what? X plus 2 would equal negative 3. Right? And so Kai gets a 5, or a negative 5, excuse me, by solving that. We get that? So the two equations, x plus 2 equals 3, so if this thing equals 3, 3 is 3 units from 0. If this thing in here, x plus 2 equals negative 3, okay, negative 3 is 3 units from 0. Okay, the linear equations we wrote in part A, we can use to find those solutions there.
So you're saying that x could be either 1 or negative 5?
I'm saying x could be either 1 or negative 5. That would, they're both true. Yeah, they're both true. Because they're both of those values, so this problem has two different answers. Okay? Both of those values will make this equation true. Sometimes we get that. We'll see it when we graph it a little later. Because the absolute value graph is a V in it. We'll see it later. Okay? Alright, let's look at this a different way. I want you to take a look at, we're going to deal with the same equation, x plus 2 equals 3, absolute value. And on a real number line, I want you to locate the point for which x plus 2 equals 0. Okay? In other words, solve this equation and find that on the number line. And then do part B and part C with your groupies, please. Huh?
19. You said 17, so I'm counting.
Okay, consider the absolute value of x plus 3, or absolute value of x plus 2 equals 3. So what value makes that 0? You guys got it. What do you guys think back there? Yeah. Way back there. All the way in the back. All you guys. You guys don't know? Yeah.
Negative 2.
Negative 2. We just solved this equation, right?
Yes.
X equals negative 2. Okay, so let's go ahead and locate it on here.
It's right there.
All right, locate 3 units, or 3 3 units from that point. What values do we get?
Oh, -1, yeah, -5.
1 and -5. Hey, note that those were our solutions earlier. Okay, so we can graph it that way as well. We can show absolute value that way. All right. Okay, we're going to take a look at, actually, you need a graphing calculator for this piece. Everyone grab a graphing calculator. You need at least one per two. If we're going to use a calculator to do absolute value, let's see if I can get some light on that. Make it a little easier. Okay, first thing you need to do is know how to graph on a calculator. And in order to do that, to make sure we don't get errors, I want everyone to clear the memory. It's always good to have an area in your notebook where you're keeping notes for graphing calculators. I usually tell students to put it at the back of their notebook. That way, anytime we want to try something with a graphing calculator, you want to reference it, you can do that. But the way you clear your memory, second plus 7, 1, 2. Second plus 7, 1, 2. Once you're done, calculator needs to be sitting on your desk. Okay? And this only works with the TI-84 or 83. Yes? Do second plus 7, 1, 2. Okay? All right, very good. So from there, we're going to go and graph. And the way we graph is we use this top line right here. This top line is for graphing. Okay? And so what we want to do is we want to set up an equation. We're actually going to enter 2 equations. Okay? Actually, we're just going to enter 1 equation. Let's just enter this one. X plus 2, y equals x plus 2, the absolute value of x plus 2. Oh, I'm sorry. Y equals the absolute value of x plus 2. Thank you for pointing that out. Okay, and so what you have to do is you have to go to the y equals menu. So find the button that says y equals. Yes? If you want to. Yeah. You take notes on it. Yep. Y equals. And in there, we have to push the absolute value symbol. Now, that's hard to find on here. Okay, pause for a minute. Everyone push y equals, get to this screen, set your calculators down. Okay, you still holding your calculator? You need help? Daisha, you need help? Set it down if you got them. You got the y equals? Are you at y equals?
No.
Push y equals.
Oh,
All right. Okay, from this point, you're going to find the absolute value symbols. You're going to go to Math. The button that says Math. Right there. You're going to arrow over one spot to this tab that says Num. So use the arrow key. And then number 1 says Apps. You hit Enter. Now, some of you that have a newer updated operating system, mine is not updated here, actually shows the absolute value symbols. Can I see yours? Okay, so those with the new TI-84, it shows the absolute value symbols. If it doesn't, you have an 83 or an older version of the operating system, I need to upgrade this one. If you have a TI-84 and it's giving you this, I can upgrade it for you. It doesn't take much. But it shows parentheses, but that's where the absolute value is. What I want in there is x plus 2, meaning you have to put x in. And there are a lot of x's on this keyboard. So if you're at this spot, your calculator should be on your table right now. Okay. The for a variable is this one right here. The xt theta n. This one right there. You're going to push that. All right. So this button. And then we're going to put plus 2. And then I have to close my parenthesis. Most of you won't have to do that. All right? And now I'm going to, like if I want to actually see the graph of it, there's the graph of that. That's what it looks like. Okay, I pushed the graph button, by the way. So if everyone hit the graph button just so you can see the graph. Pretty neat. That's not really what we're using this for right now. What I'd like you to look at, I would like you to look at the table. Find the table key. Where's the table key? Second graph is table. Second graph. Now, what I want you to focus in on, remember what our solution to this was. What were our solutions just a minute ago? Negative 5 and 1. Remember back to here. Negative 5 and positive 1. I want you to find when x is 1, what does it say y is? 3. Now I want you to find negative 5. So you have to scroll up. What does it say y is? 3. Dude, if I looked at my graph at negative 1, excuse me, I got to go back here real quick. Sorry, at negative 5, we would have 3. At negative 1, or excuse me, at 1, we would also have 3. You would hit your graph in the same spot. This is why you have two solutions. They're reflections of each other about this piece. Okay? So there's another way you can do it. You can use a table. You just use the table to figure out the same values. What we're going to do today is we're going to solve them algebraically more than anything. Okay? So, you can answer the rest of this later if you'd really like to, but right now, we're going to skip around here. Student journal, later on when you get home, you can fill out this if you'd like. Look at some of your notes, add some notes to it. But I want to try some problems. So go ahead and take a look at your note page. And our title is 1-4, Solving Absolute Value Equations. All right, couple properties to remember. Absolute value, it always has to be greater than 0. If you have an absolute value of negative a, it equals the absolute value of a. And we'll go through these properties here as we work through today's stuff. Absolute value of a times b is the same thing as the absolute value of a times the absolute value of b. Same thing with division. You can break apart that absolute value. There's a fraction in there. All right. So there's our core concepts. Let's try some problems. I want you to take a look at problem number 1 on this. Go ahead and tell your neighbor. Work with your groupie. Come up with the solution there. Monitoring progress is out of your textbook. It's not in your student journal. So you're not going to find this in your journal right now. Okay, so let's remember what this is asking. This is saying, what number is 10 units from 0 on a number line? Yeah, so if it helps, draw the number line. Here's 0. Here's one way we go to 10. And here the other way we go to what? Negative 10. Those are our solutions. We start at 0 and we move 10 units. So if you make the inside of the absolute value equal 0, this just tells you how far to move. So in this case, to make the inside 0, you have to say x is 0. And then you move 10 units either way. So like on number 2, when I'm looking at that one, oh, by the way, we would write this as x equals plus minus 10. That's kind of the lazy mathematician way of writing it. We only have to write 10 once. All right, so on number 2, Mac, You are being like mass distracted. What is going on? Okay, you get 5 seconds to find a pencil. Otherwise, you get to sit there. Okay, hurry up now. Quit being a distraction. All right, so this right here, we're trying to make 0. What will make this 0? Yeah, if x is 1, that's 0, right? All right, so we want to go to 1 on our number line. That's where we start. And how far do we move? This is how far you move. We move 4 units this way. 1, 2, 3, 4. So that's 2, 3, 4, 5. That's one answer. The other answer is this way, 4 units. 0, -1, -2, -3. So here, x equals -3 and 5. Okay. You guys, another way to think about this question.
Why would you start at 1 instead of 0? I thought it was how many spaces in between.
It's what makes this in here 0. Okay, so another way to think of it is this way. Okay, let's think of it algebraically. If x minus 1 equals 4, that means this thing right here, x minus 1 can equal 4. Okay? What other number could we put in here that's 4 units from 0? All right, let's try it this way. If I had this, what are the two values that make that true? 4 and -4. How many are with me on that? Okay, 4 and -4. So let's pretend for a minute. Now, let's say I have this. What two numbers can go in there to make that true? Yeah, what two numbers are 4 units from 0? 4 and -4. Same two numbers, right? You guys with me? All right. Now, this is going to be magical here in a minute. Using my cool magic trick. Ready? Check it out. What two numbers go in there that will make that true? 4 and -4. So you're telling me that in here, I could put a 4 or a -4. You're telling me that in here, the thing in here has to be 4 or -4. So that says x minus 1 has to be 4, or x minus 1 has to be -4. It has to be one of those. Right? Don't let the thing inside confuse you. Okay? Whatever's in here has to change to 4 or -4. If x minus 1 equals 4, well, we add 1 to both sides. What's x? 5. That's that number. Here, we add 1 to both sides. What's x? X equals -3. That's that number. You guys with me? Okay, I'm going to skip this number 3 because it's about to confuse you. Let me give you a different problem here. Okay? Let's go with this. The absolute value is going to equal 9. Okay, now right now, hopefully in your head, you're thinking of two numbers.
9 and -.
All right. Now you don't give it away. All right? Here it is. X minus 7. Find the solution. Two solutions there.
So would you start from 7 on a number line if you were doing this?
Okay, compare with your neighbors. Talk to them about it.
What'd you get?
I got -2 or 16.
How many of you match with the people around you? Okay. Hey, let's see if we've got it. Now, I'm using my magic props again. The thing inside there has to be equal to what two numbers? -9 and 9. We call that a negative case and a positive case. Why? Because one number's negative, one number's positive. That's why. We're really crafty like that. Okay? Negative case, positive case. Now, the thing in here has to be 9 or -9. The thing in there is x minus 7. Okay? So, algebraically I solve it. I add 7 to both sides. I get -2. How many had -2 as an answer? You are correct, Amundo. And I add 7 to both sides here. I get 16. X equals 16. How many had 16 as an answer? You are also correct, Amundo. Now, when we graph it, really, my graphs, I do not need them perfect. I just want 3 numbers on. Well, you can put 4 numbers if you want. Some of you actually maybe use the graph to solve. Okay, if you use the graph to solve, you probably put 7 here, and then you moved 9 units each way. So you started at 7, and if I go 9 units this way, I'm at 16. And I go 9 units this way, I'm at -2. That would be fine. That would actually be preferred. If you'd like to put the number 0 in here somewhere, in the appropriate spot, that's great as well, just so that we can. That's perfect. You don't have to put all the little markings. Do not be the number line artiste. Okay? You're like, dude, oh, You're like, man. Okay, we don't need that. All right. We good? Everyone rate themselves 1 to 5 right now. About to throw you for a loopish. Maybe.
Wait, what do you mean later?
5 means amazing, I get it. 1 means I don't get it. Okay, here we go. Tell your neighbor what you know about absolute value. Yeah, what do you know? Perfect. All right, time's up. Give me some answers. What do we know about absolute value? Mac. Good, it's distance away from 0, meaning it is always what? Absolute value is always what? Okay, here's number 3. Okay, come up with the answer. You work together. Now remember, if I use my magic trick, oh, hold on. My prop needs to be edited. There we go. Edited it. If I use my magic trick, what's that saying? It's saying what number is -3 units from 0? All right, talk about it. Think about that. All right, time's up. So what do we got? Matt?
I got -1.
-1 is -3 units from 0. Okay? Any other numbers from -3 units from 0? How many of you have ever ran like a negative mile? Hey, like when you start driving your car, maybe like driving negative miles?
What?
You like go back in time or something? I don't know how that works. If you throw it in reverse and start driving backwards, you don't actually drive negative distances. Hey, guys, I'm not joking about it. Absolute value is a what? Come on, you guys just told me this a minute ago. What does absolute value mean? Distance. Absolute value is a distance.
Yeah.
Is that possible?
No.
Can you go a negative distance? No. Your absolute value, if that's the only thing over here, which it is, it's my absolute value house. It's right there, dude. Things inside, okay? We got our occupants in there. This house, this absolute value cannot equal 0. This is a no solution. Absolute value can't be 0. Absolute value cannot equal negative. Or, I'm sorry, absolute value cannot equal negative. It can be 0. Absolute value cannot equal negative. You knew that? Oh. All right. Absolute value cannot equal negative. Questions? All right. Let's try a few others. Why don't you take a look at number 4 there. Solve the equation and check your solutions. Solve it. Work together. Talk about what your plan is. Anyone know what the first step would be here? Taylor?
Subtract 5 from both sides.
Okay, Brian? Same thing?
Subtract 5.
Okay, Kaylee says the same thing. Sarah, what were you going to say?
I was going to say that.
Okay, you were going to say that? Hey guys, why would I subtract 5 first?
You need to get the absolute value.
I gotta get the absolute value alone. So subtract that 5. So get x minus 2 equals 4. Okay? Now if it helps you, you can always do your cool guy thing where you have a little piece of paper, like fingers work as well, like where you put your finger in there. But look, you're saying what two numbers are 4 units from 0? 4 and negative 4. So really you're saying your answer could be negative 4, your answer could be 4, and then you say, well, that thing has to be out here. X minus 2 has to be negative 4, and x minus 2 has to be 4. Those are my two possibilities. Here, x equals 6. Okay, how many got 6 and negative 2? Okay, if you're graphing, by the way, this is 6. This is negative 2. What's in the middle?
4. Wait, no.
Yeah, it's 4, right?
You're doing great.
Yeah, it's 4.
Wait, why would it be 4?
No, hold on, it's not 4.
Yeah.
No, it's not.
Do we have the right answers here? Hold on, let's check.
What about the 5 though? Don't we need something?
Yeah.
No, we moved the 5. Nope, don't have to move the 5. Hey, what goes in the middle?
0. Because in between 4 and 4.
Oh, we got it backwards. It's not the
2.
It's 2 that's in the middle. Good. Right? It's the thing in the inside. It's what makes that 0. Okay?
Yep, it's 2. I did the thing where you don't.
All right. Give 5 a shot.
5. I have a little no room. I have room for one more problem.
Let's check it out, you guys. We don't ever distribute something into absolute values. I know. So those of you that did that, that's okay. Now you made the mistake. You won't make it again. So they're multiplying by 4. So to undo that, get rid of it, divide. You got to get the absolute value alone. That cancels. 2x plus 7 equals 4. So what's our negative case? Negative 4. And what's our positive case?
4.
Positive 4. You guys tell me if I go off the screen like that, please. 4. So this becomes 2x plus 7. And 2x plus 7. Solve it up. Subtract 7 on both sides. Get 2x equals negative 11.
Would you drop the whole 2x plus 7 down and then wouldn't that equal 4 and then
And then do, yeah.
So approximately 5, or not approximately, equals negative 5.5, right?
Oh dang. I got negative 4.5.
Okay, negative 1.5. Just out of curiosity, how many got that? How many know where they made their mistake?
Oh, I know.
I
Yeah, I
didn't
totally
mistake, I
missed
just
it.
didn't know how to use the software.
Okay, well, let's graph it real quick. If I graph it, I have negative 5.5 and negative 1.5. What goes in the middle?
That would be
What's halfway in between?
like 1.
Oh, count up. 1.5, 2.5, 3.5, 4.5, 5.5. What's in the middle? Yeah. 2.5, 3.5.
2.5.
Is it? 2.5, 3.5, 4.5, 5.5. That's a distance of how far? 4. See my 4 fingers? See my bling? Okay, 4. You got 4. So if I want to go halfway, I go how far? 2 more units, man. 3.5. Come on, guys. Halfway between 1.5 and... Unbelievable.
I told you that.
Shame and eat.
We're in the car.
Okay, put the dot here, dot here. Hey, our solution, x equals negative 5.5 and negative 1.5.
We are kindergarten.
Holy moly.
We are children.
Okay, try number 6, please. Hey, last one.
I don't have any more room.
Sorry, last one for today. Sorry, last one for today. Find a new spot. Be artistic, man. You can do it.
Get on the margins.
Except for not on my desk. Okay?
Oh, those.
Give it a go.
Those math.
Okay, you guys, for those of you that are kind of stuck or you want to make sure you're doing it right, just keep this in mind. If you have things, like when you draw your line here and you separate your equation, if you have things outside of the absolute value, Mercedes, pay attention. If you have things on the outside of the absolute value, in this case, what 2 things are on the outside here?
Negative 2 and negative 3.
Negative 2 and negative 3. You've got to move those to the other side first. So how do I move the 3?
You add it on both sides.
We add 3. Okay, now that leaves negative 2, absolute value, 5x minus 1, equals negative 8. And now we get rid of the negative 2, we divide by negative 2. Those cancel. I'm left with the absolute value of 5x minus 1 equals negative 8 divided by negative 2 is 6, or is 4, excuse me. Almost messed it up. Okay, so from there, now you do your cases. You have the absolute value alone. Now you're saying, this is where you use your magic trick, your magical piece of paper. Okay, which this is the wrong size. Hold on, you gotta edit your magic props sometimes. Okay, because that just makes it easier. You know the 2 answers, 4 and negative 4 then. You don't get hung up for all the other junk. You know your negative case is negative 4, and you know your positive case is 4. Oops, that's positive again. Let's go 4. Okay? The negative case is negative 4. That means this thing inside has to equal negative 4. And this thing inside has to equal positive 4. Okay? And then you solve it. Did you guys get 0 for one of them?
No.
Uh-oh. What did I do wrong?
Something.
You wrote it wrong. You did 5x minus 4 instead of minus 1.
Good. Hey, what did I do wrong?
Oh, yeah, 5x.
Come on, evaluate my work. Everyone should be looking up here, comparing your work to mine. What did I do wrong? Man, I don't have the whole thing on the board still. You guys gotta tell me when I'm off the screen.
It's not worth it.
What did I do wrong? Yeah. So which one should it be? Should it be 5x minus 4 or 5x minus 1? Yeah, it's this, right? It's this thing. 5x minus 1. So this was wrong. Did I purposely do that?
Yes.
Maybe.
At negative 3. So my answer is actually negative 3/5 or x equals negative 0.6. Okay, either one works. Okay, add 1, add 1. 5x equals 5, x equals 1. All right. You didn't get that? Oh, we'll have to look.
She got 0.5 and 3.9.
Okay, guys, I'm going to pause there. I want you to take your student journal. I'll check yours here in a minute. If you guys need help, you can keep that out. But take your student journal and open it up to page 20. Page 20, please. Yeah, it's now page 20. 17 was our note page. So page 20, you look at the bottom, and you have your extra practice. Your assignment today... Stay focused with me. Your assignment today is to complete problems. Problem 1 on page 20. And then turn to page 21, please. Okay? I want you to complete 2 through 5. Alright? So 1 through 5, page 20 and 21, 1 through 5. We're going to use the other problems as part of our lesson tomorrow. Okay? Ask for help right now if you need it before you leave today, please. Okay?
That's because I was wrong.
Everyone's eyes and ears, focus up here, please. Okay. 5 seconds of me asking. You guys have to have it. Jonathan, you sit down just for a minute, please. Okay. You guys, on this first one, here you do it. You go through the same process, right? This is 3x plus 12 equals 0. You're saying what two numbers are 0 units from 0? Well, reality is, are there two numbers 0 units from 0? No, there's only one number 0 units from 0, and it is 0. So if your absolute value equals 0, how many answers will you get? You'll only get one answer. So you just set it up, 3x plus 12 equals 0, and solve. And then plot that point. Okay? All right, keep asking questions as I'm